students, a warm welcome to all you students. Now today's class is about mirrors. Okay? So what is a mirror? Okay, so a mirror, it is a smooth and highly polished surface. Okay, it is a very smooth and highly polished surface. Okay, let's take the example of the looking glass. Okay, the mirror which we used. Okay, now to see ourselves. Okay, that is let's take that as an example. Okay, now a mirror. Okay, now how is it made? Okay, now just like the glass window. Okay, now we'll take a glass. Okay, and then on one side of the glass, okay, it is being coated. Okay, coated by what? By compounds of silver. Okay, why do we use silver? Because silver is the best reflector of light. Okay, we cannot use just silver because silver is very costly. Okay, so that is why it is being coated with compounds of silver, and then over it, it is being coated by red lead oxide. That's why at the back of the plane mirror, okay, which we use in our home, you will find that there is red color. Okay, that is lead oxide. Okay, which is used for protecting the silver. Okay, the silver. Okay, which is used for reflecting. Okay, now mirror are classified as plane and curved. Okay, there are two types of mirror also. They are plane and curved. Just from the word plane means straight, right? Okay, which like the mirror which you used at home. Okay, that is a plane mirror. Okay, now some characteristics, okay, of the plane mirror. What do you observe? Okay, now you have this mirror, okay, at home, and then what happens when you walk towards and backwards? Okay, forward and backward. Now you will observe that the size of the image and the size of the object will be the same. Okay, so that is the first characteristic of the plane mirror. The size, the image size and the size of the object, they are the same. The second is that now that mirror, okay, and you place a screen, okay, you will observe that no image will be formed on the screen. So it is virtual. Okay, the image is virtual. Now the third point is that, okay, it is virtual and it is erect. Okay, it is erect, and then the image is also formed behind the mirror. Okay, that is can be done with the help of a ray diagram. Okay, and also it is laterally inverted. Just like I said previously, when you wave your left hand, actually in the mirror, the right hand is actually waving. So that is the characteristics of the image formed by a plane mirror. So now we'll go next to the concept of curved mirror. Okay, now curved mirror, okay, it is a mirror in which, okay, in which what? In which the polished surface is actually curved. Okay, if you observe for a plane mirror, okay, now it is being represented like this, straight line. Okay, and this part represents the polished part, and this is the reflecting part. Now, for curved mirror, the polished surface, it is curved. Okay, based on the curvature of the polished surface, also it is being classified as spherical and parabolic. Okay, now this is when it is a part of a hollow sphere. Okay, when it is taken as a part of a hollow sphere, that is a spherical mirror. But when it is taken, okay, out of, okay, a parabolic, okay, you see here it is more curved than the spherical mirror. Okay, so that is a parabolic mirror. Okay, so now we'll be doing in detail regarding spherical mirror. Okay, now spherical mirror is a mirror in which it is a part of a hollow sphere. Okay, it is a curved mirror, but which is a part of a hollow sphere. Now they are classified as concave and convex mirror. Okay, spherical mirrors, there are two types, concave and convex. Okay, now this part, okay, is is the bulging part, right? Okay. Bulging part, or you can say the outer part, and this is the hollow side. Okay. The bulging side, okay, sorry, and this is the hollow side. Now this, okay, it represents the polished and this is the reflecting surface. Okay. Now when, okay, the hollow side, okay, now is when the polished surface is actually on the bulging side, now that is a concave mirror. Okay, and when the reflecting surface is in the towards the hollow side. Okay, so on the hollow side, I mean, it is a concave mirror. But for a convex mirror, okay, the polished is actually what? The hollow side. You can see the difference, right? This is bulging, but this side it is the hollow side. Okay, but the bulging side, okay, it is actually the reflecting surface. Okay, so this is a concave and this is a convex mirror. Now we will be doing about the terms associated with the spherical mirrors. Okay, important terms. Okay, so now we'll be doing the general terms, okay, associated with the spherical mirror. Okay, so first, okay, okay, pole. Now a pole, now it is what? The midpoint, okay, middle of the spherical mirror. That is the pole. Okay, now this P here is the polished surface. Okay, and this is the reflecting surface, but this is the midpoint of the spherical mirror. Then an imaginary line is drawn through this pole. Okay, now this imaginary line is called what? The principal axis. It's called the principal axis. And then, okay, because this concave mirror is a spherical mirror, now which is a part of what? Of a hollow sphere, right? Which is a part of a sphere. So we have a center, right? A sphere always has a center. So that C is called what? The center of curvature. Okay, so this is called the center of curvature. Okay, but when rays of light, okay, they hit this concave mirror, obviously it will get reflected. Okay, so it will get reflected and up, and those, okay, you will actually appear to meet at some point, okay, or they will meet at this point or appears to meet at this point. Now this is called the principal focus. Principal focus. Okay, so we have the pole, the principal axis, the center of curvature, and then the principal focus. Okay, and then the distance between the focus and the pole. Now this is called what? The focal length. Okay, it is called the focal length. However, the distance between the center of curvature and the pole, it is called the radius of curvature. Okay, so this, okay, this distance is the radius of curvature. Okay, radius of curvature, it is denoted by the letter R, and focal length, it is denoted by the small letter f. Okay, and there's a relation between the radius of curvature and focal length. Okay, and the relation is that R is equal to twice f. A very, very important formula. Okay, so to locate this focus, make sure that it is in the middle of C and P. Okay, in the middle of C and P. Okay, so that is the principal focus. Now this is for concave mirror. Now for convex mirror also it will be the same, okay, the pole, the principal axis, all of these, but it's just that, okay, it's just that, okay, this is a convex mirror, okay, the polished surface is toward the hollow side, okay, hollow side, but it's just that, remember the speed, okay, now we have here towards the left, right, towards the left, but for a convex mirror, they are towards the right, okay, they are towards the right. In other words, just remember that they should be towards the hollow, okay, hollow side. You see, they are within this hollow side, so this one also should be within the hollow side. That will be easier to remember, okay, but the definition and everything, they are the same, it's just the location. Now we will be studying in detail, okay, the image formed by a concave mirror and a convex mirror, okay. But before that, okay, like we'll be able to do that with the help of ray diagrams, okay. But there are certain rules, okay, for to draw ray diagrams. Okay, the first is, okay, actually in any order also, but this is a concave mirror, this is a convex mirror, okay. So a parallel beam of light, okay, a parallel beam of light, what happens when it strikes this mirror, okay, after reflection it will always pass through the focus. That is the first rule, okay, that is the first rule for, that is the rule for a concave mirror, okay. But for a convex mirror, okay, this is a convex mirror, and then when the parallel beam of light strikes this reflecting surface, now, yeah, they will, however, appear to meet, okay, appear to meet at the focus, okay. Actually, it's like coming out from the focus, okay, but actually they will meet at the focus. Here also, it will pass through the focus, here also, but it's just here that it meets, but here it appears to meet, okay. Now, the next rule is that, okay, however, now, this is for a concave mirror, I've taken only for concave mirror. Now when a ray of light it passes through the focus, now it will, when it strikes this mirror, okay, after reflection it will come out as a parallel ray of light, okay. So the reflected ray will be parallel to the principal axis, okay. So when it passes through focus, it will come out as a parallel ray of light to the principal axis, okay. And the third is that, okay, when it passes through the center of curvature, now it will, okay, it will also be reflected back through the center of curvature. Look, this is reflected, but after striking this mirror, it will pass through the center of curvature again, okay. For the convex mirror also it will be the same, okay. So now we'll be doing the image formed by a concave mirror by using ray diagrams. Okay, so suppose we have a concave mirror, okay. Like there's a concave mirror, there's a concave mirror here. Now, very interesting part about concave mirror is that, okay, suppose, you held the position of the concave mirror in the same position, okay, but take what yourself as the object, okay. Now you are the object, and then you have placed what, a mirror, concave mirror, now in its exact position, okay, same position. Now what happens, now you see here, is that when you are near to the mirror, okay, now you will find that the size, okay, basically the size, now it will be quite big, okay, it will be quite big and it will be erect, okay, just like when you're looking at the plane mirror in your home, okay, you will see an erect image, but it will be quite big, okay, and then you move backward, okay, you move backward, and then you will reach at the focus, okay. Now when will you know that you have reached the focus? Now the image formed in the concave mirror will be very enlarged, okay, very big, Okay, actually you can't even see yourself because it will be very big, but it will be inverted. Okay, it will be real and inverted, but it will be very enlarged. And then you move backwards again. Okay, then you will be here between F and C. Okay, you will notice that it will be again enlarged. Okay, again enlarged means it will be again big, but it will be real and inverted. Okay, means that your head will actually be down. Okay, then again you move backwards. Now you will reach here. Okay, at C. Now at C again it will be real and it will be inverted, but the size it will be the same. Okay, it will be the same. Then again you move backwards, it will be beyond C. Okay, this position. Then you will find that the size of the image is very small, very small. But then again the image will be inverted. But beyond C, okay, at a very large distance, okay, away from the mirror, the size of the image is extremely small. Okay, extremely small, and it will be inverted. Okay, so you will find that only when it is near the mirror, it will be erect but quite big. Okay, and then quite bigger. Okay, quite enlarged, and then later you will reach at a stage where it will be same size and then diminished. Okay, so we'll do only 2 ray diagrams. The rest, okay, you do by yourself. Okay, so for the first one, I've chosen it is between C and F. Okay, and for the second one, it is at the principal focus. So I'll be doing the image formed by a concave mirror. Okay, by using ray diagrams, and 2 positions is between C and F and at F. Now between C and F, okay, I've drawn the concave mirror, the principal axis. Okay, you mark the pole, the focus. Remember that the focus should be in the middle. Okay, between C and P. Okay, it should be between, okay, C and P. And then here we have the object is between C and F. The object means the position of the object. So make sure that it is exactly in the middle between C and F. Okay, because if it is not, then you will not get the image. Okay, so you with the help of a ruler, you mark, okay, and then you place the object. Now we'll be concentrating only this tip, okay, this tip of the object, A. Okay, I've marked it as A. Now when you know the image of this tip, obviously the rest will follow. Okay, so a parallel beam of light, okay, will be emerging from this point A. Okay, so we'll draw. Okay, we'll take only one, okay, ray of light. Okay, then what happens is that this ray of light, it will strikes this mirror. Okay, now as a result of reflection, it will get reflected, but this is parallel. Okay, the first rule says that a parallel ray of light will pass through what? The focus. Okay, so you have to remember the rule. Okay, so this parallel ray of light will pass through the focus. Make sure, okay, when you draw, it should be exactly correct. Okay, like passing through this, okay, focus, and then you extend this. Okay, you extend this, and then next, okay, from the tip that is at point A, you take another ray of light. Okay, but it should pass through C. Okay, pass through C. And then after this you extend. Okay, so always remember when you draw a diagram, okay, a parallel passing through focus and another is through the center of curvature. Okay, so this, it will get reflected along the focus, and then another passing through the center curvature and reflected through the along the center of curvature itself. Then the point of intersection of this reflected ray, you see they are, okay, they are intersecting, right? Okay, now this, now you see here we have taken only for this tip, okay, and we have found, it is formed here, okay, it is formed here. So this is what the image of A. So we have taken it as A prime. Okay, so then after this, we draw a line through this. So we find that A, okay, A prime, let's take this as B prime. So this AB, okay, is the object, and then this is the image. Okay, this is the image. So what do you observe is that the size of this, first the size. Okay, now what happens to the image? Quite enlarged, right? Okay, so the size is enlarged. Now what about the position? The position is between C and F for the object, but for the image it is beyond C. Okay, then what happens? And also you observe that it is what? It is inverted. Okay, it is inverted. Okay, look upside down, right? This one is here. It is actually upside down. Okay, so this also, it meets at some point. Okay, so that is real and inverted. Okay, so the image is real and inverted. So next we'll be doing when the object is at the focus. Okay, so you have placed the object at the principal focus exactly, and then the rule is you draw a parallel beam of light, okay, from the point A. Okay, you draw a parallel beam of light from the point A, and it strikes the mirror. Okay, it strikes the mirror, and after reflection, it will pass through the focus. Remember that? It should pass through the focus. Then we have to take another ray of light again from this point A, but it has to pass through the center of curvature. Okay. This is the incident, okay, incident ray, but you know that it will be reflected along this. So this is the, So what do you observe? Okay, this is the object, right? And then you will find that after extending the reflected rays also, okay, it will like within limits, okay, like you cannot find the point of intersection, okay, but somewhere at infinity they will meet, okay, so which means that the image is formed where? At infinity, means very, very far, okay, and this is the size of the object, but the size of the object in this case, it will be very, very big, okay, very enlarged, okay, and also the image, okay, being formed somewhere at infinity, it will be real, okay, they will meet, okay, and you know that real image is always inverted, so the image is real and inverted. So at focus, the size will be enlarged, it will form at infinity, and it will be real and inverted. So what happens, okay, to the image formed by a convex mirror? Okay, now if you place a convex mirror, okay, and then you are the object. Now you will find that as you walk away from the mirror, okay, it will always be erect, okay, it will always be erect, but then you will find that the size, okay, it will be diminishing, okay, as you keep on moving backward, the size will also keep on decreasing, okay. So I've taken okay, to illustrate this, okay, with the help of a ray diagram, okay, I have placed the object, okay, near the pole, okay. Actually, at infinity it will be very, very diminished, but when it is near the pole, okay. Now we'll try to see what happens to the image. Now, just like in the case of concave mirror, okay, from this point O, a parallel, okay, a ray of light which is parallel to the principal axis, okay, is drawn. Okay, so okay, you draw a line which is parallel to the principal axis, okay, till it strikes the mirror. Okay, then according to the rule, it says what? That a parallel ray of light, okay, it will always pass through the focus, okay, but in the case of convex mirror, it will appear to diverge, okay, it will diverge. So okay, then again from this point A, you draw a ray passing through the center of curvature. Okay, parallel, focus, and then center of curvature, okay. So okay, so the point of intersection, okay, of these lines, now you will get it, okay, that is the image. Now we have taken only for this tip, okay, so this point of intersection will give you for A, okay, so A prime, and then from there you extend a line, okay, so that will be the image of this point, of this object AB, okay, A prime, A prime. So what do you see? Okay, the characteristics. Okay, now the size here, okay, and the size here. It's quite small, so diminished. Okay, and then what happens? Is it erect? Yes, right? Here, here. Look, it's not inverted. Okay, so it is erect. And you know that, okay, it actually appears to meet at some point. Okay, so it is virtual. Okay, it is virtual and erect. Always remember when it is erect, like when it is virtual, it's always erect. They are connected. Okay, and then where it is formed between P and F. Okay, so for convex mirror, there are only two cases, not like concave. There are many cases. Okay, for convex is that when you place near the pole, okay, or beyond this, but not at infinity, okay, you will find that the image will always form between P and F and always diminish, virtual and erect. But at infinity, okay, it will be highly diminished, but it will be formed here. It's called focus. Okay, so for that you do by yourself. Okay.